All right, in this video, I'm going to be going over some basics of probability, such as talking about what a sample space is, how you could develop that, and then answering three little easy probability questions. So, top example, we're going to roll a six-sided dice, then pick a marble out of a bag containing two blues and one yellow. We need to list the sample space. So what I'm going to do is I'm kind of going to make a tree of options here. So I'm going to make it vertical and it's going to kind of trickle down. So the first thing I'm going to look at is rolling a dice. So thinking of rolling a dice, how many different options do I have? Well, I have six. I could roll a one, so I'm going to make some branches here, branching off to all six options. I could roll a one, a two, a three, four, five, or six. So 1, 2, 3, 4, 5, and 6. So I have six options for rolling a dice. The first thing I did is I roll that dice. Then I'm going to pick a marble out of a bag that contains two blues and one yellow. So after I roll a dice, so say I rolled a 1, then I have to pick a marble. Well, I have three options there. I could pick a blue, the other blue, or a yellow. But here's the deal. I have those three options after every single dice roll. So I could roll a 2, then I have the option of a blue, or a yellow. I could roll a 3 and get a blue, or yellow. Roll a 4, get a blue, or a yellow. Same thing with 5 and 6. So I had my dice, and these are my marbles. So those are two different events that happened. The first event is I rolled a dice. Second event, I drew a marble. Finish that out. All right. So the way this kind of tree helps you come up with a sample space is if you start at the top and follow all the way down all the branches, you could figure out what one of your potential outcomes is in this sample space. For example, I could roll a 1 and then have a blue. So I could have a 1B. I could also roll a 1 and get the other blue. So I have 1B again. Notice that it can happen two different ways, but I list both of them out. It's okay to have that. Then I can have a 1 and I could have a yellow. So 1Y. Now follow the branches here. I could roll a 2 and a 2 and a blue again, and a 2 and a yellow. So I got 2B, 2B, 2Y. And then you can kind of see how this pattern is going to go. You know, I could roll a 3 and get a blue, the other blue, or Y for yellow. So I can get a 4B, 4B, and a 4Y. I can get a 5B, a 5B, and a 5Y. And I could get a 6B, a 6B, and a 6Y. So all of this list right here, that is my sample space. I could get one blue, one yellow, a 2 blue, a 2 blue, a 2Y or yellow, 3 blue, a 3 blue, or 3 yellow, 4 blue, 4 yellow. You get the idea. So we could also ask, how big is this sample space? So what are all the outcomes? Well, that just comes to counting up all the different outcomes. So all of these are a different outcome, and this is the sample space, is the collection of all of my outcomes. So if I wanted to count all of these up, I could figure out what is the total size of my sample space. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 total outcomes that can happen. So there's 18 total outcomes. That's going to be important, especially when we get into my second and final example here. So I have a bag that is filled with 4 red marbles numbered 1 through 4. So I can get a red 1, a red 2, a red 3, a red 4. It also has 3 blue marbles, so I can get numbered 4, 5, 6, 7. So I can get What color is this? Blue. So B5, B6, B7. So that's my sample space there. So that's good to know. I have 1, 2, 3, 4, 5, 6, 7 total outcomes in that sample space. So the first question is, so you draw a marble at random. What is the probability that it is a red marble? So here's how it's going to work. We're going to write this as a fraction. So let's figure out how many total times we can. So it's the total of the event is what we're looking for, divided by the total outcome. So I'll show you what that means a little bit more. So the probability that is a red marble. So how many total red marbles do I have? Well, I have 1, 2, 3, 4 different ways I can get a red marble. So I'm going to have a 4 in the numerator of this fraction. In the denominator, I need the total outcomes. Well, there's 1, 2, 3, 4, 5, 6, 7 total outcomes that could have happened. So the probability that it's a red marble is 4 out of 7. And then I have, it is an even numbered marble. So completely separate from A, this is a different question. It is an even number marble. Well, how many different ways can I get an even number marble? Well, I can get a 2, a 4, or a 6. So that happens 3 times. But we divide it by the total number of possibilities. So if I'm reaching into this bag, there's still 7 total possibilities of drawing, 7 different ways I could draw this marble. But only 3 times does it happen to be an even. And then my final question, it says it's a red and an odd number. So I need to count up how many total times do I have a red and an odd number at the same time. Well, it happens once, twice, so only 2 times. So I'm going to have 2 total times I can get a red and an odd number divided by, well, how big is my sample space here? Well, I can still draw any of those marbles, so 7. So 2 out of 7 times that I get a red and an odd number. 3 out of 7 times it's going to be an even numbered marble. 4 out of 7 that it's going to be red. And that is basics of probability.